Hello, YouTube. We're back. Okay, so we are doing, what are we doing? We're doing real zeros today. Don't forget tonight's homework, page 251, multiples of 10. If you want to use the 2-for-1 coupon, you have to show me the latest 2 homeworks that you haven't shown me yet. Alrighty. So, riddle me this. We're going to be talking about several theorems today that involve solving polynomial equations or factoring, really, okay? So if I ask you to factor this or to solve this equation, x cubed minus 4x squared plus 2x minus 5 equal to 0, can you solve that by factoring? As a matter of fact, you can. All right, let me remind you that you know some stuff. What does the fundamental theorem of algebra state about this equation? You can find at most 3 different real roots. They don't have to be different. You can have repeated roots. They don't have to be real. They could be complex. But you're looking for at most 3 different real roots. Okay. Let's say we can factor this one. I'm going to say that x minus 3 is a factor. Am I lying? Or am I telling the truth? How do you know? Well, if that's the case, what's a root? If you said x minus 3 equal to 0, what's the root? 3, right? So what I'm saying is that 3 is a root. How do I know that? I don't know that. I made that up. But how do you know if that's true? How do you know if this is a factor, if it goes in evenly and has another factor? You can divide. How do you figure out this? You can divide. All right, let's divide. What's x minus 3 divided into x cubed minus 4x squared plus 2x minus 5? Okay, go ahead. How many times does x go into x cubed? Just divide x cubed by x. What do you get? 1x squared. Why? Because you know how to do long division. X squared times x is x cubed. So they're going to cancel when you subtract. Remember, dividing is just a lot of subtracting, right? And x squared times negative 3 is negative 3x squared. So go ahead, subtract. How do you subtract? Never do. Add the opposite. And you get what's negative. They cancel, right? And what's negative 4x plus 3x squared? Negative 4x squared plus 3x squared is negative x squared. All right, now what do you do? Remember, you know how to do long division, don't you? Bring down the next term, because I'm dividing by a binomial. I need a binomial. Okay. And how many times does x go into x squared? 1x, right, because x times x is? Oh, yeah, by the way, yeah. X into negative x squared is negative x. What are we saying? Yeah, okay. Different version of Smartboard is messing me up here. Okay. All right, so x into negative x squared is negative x because negative x times x is negative x squared. If these don't match, you messed up. And negative x times negative 3, positive 3x. Then you're going to add the opposite, and you get negative x. Right. Now what? Bring down the 5. How many times does x go to negative x? Negative 1. So negative 1 times x is negative x, and negative 1 times negative 3 is positive 3. Then you're going to add the opposite, and you get negative 8. So is that a factor of x cubed minus 4x squared plus 2x minus 5? No, you have a remainder. You've just discovered the remainder theorem. There's 3 theorems we need to do this stuff. First, the fundamental theorem of algebra says we're looking for at most 3 real roots, right? The remainder theorem says to test a factor, you don't have to divide it out. Look, let's start over. If x cubed minus 4x squared plus 2x minus 5 equals 0, if this is true, I would not get a remainder, right? Okay, now let's say that's f of x. That thing I'm solving. I'm trying to find the zeros of f of x, right? Okay. And you told me that if x minus 3 is a factor, what was the root? 3. What's f of 3? Plug it in. What do you get? Okay, 27 minus, 36, plus, well, 2 times 3, 6 minus 5 is how much? Not just 8, negative 8. Isn't that the remainder we just got a minute ago? That's the remainder theorem. All right, so if x minus 3 is a factor, then 3 is the root. If 3 is the root, you don't want to see negative 8 here. What do you want to see? 0, right. So you have two pieces of information. You can find when you get a 0 right away, or you can find out what the remainder is. Okay. That's 2 out of the 3 theorems. Here's the third one. How do you guess a good root? Here's a new function. Let's say f of x is now 2x cubed minus x squared plus 2x minus 3. I want to know when that's 0. And what's a good guess? It's guess and check, but there's a way to guess. This is called the rational roots theorem. If this has any rational roots, not just real, but rational, they look like factors of the last coefficient, negative 3, divided by factors of the first coefficient. What are factors of negative? Negative 1 and positive 3, right? Or positive 1 and negative 3, right? Okay. Over. What are factors of positive 2? Positive 1 and positive 2, or negative 1 and negative 2. One of these combinations might be a root. Yeah. The theorem states that if one of the roots is rational, remember what rational means? Fractional. Right? A ratio made up of an integer over an integer. That's a rational number. Okay? It's made up of factors of the last coefficient, negative 3, divided by factors of the first coefficient, positive 2. So what are you getting? Well, you're getting negative 1 divided by 1. That's an answer. That's a possible answer. Positive 1 divided by 1. That's a possible answer. Positive 3 divided by 1. That's a possible answer. Negative 3 divided by 1. That's a possible answer. Negative 1 divided by 2, that's a possible answer. Negative 1 divided by negative 2, that's another possible answer. Positive 3 over positive 2, or positive 3, or negative 3 over positive 2. Those are all the combinations. Let's try an easy, let's pick one. I'm going to assume it's easy. What's the easiest root I just stated? 1. Let's see if it works. If the root is 1, what's the factor? Not just x. What's the factor? X minus 1. If 1 is a root, x minus 1 is a factor, and I need to know the other factor to solve for all the other roots. I know this, if this is true, the root is 1, yes? I need to find this factor to get the other roots. Now, right, why don't I just plug in 1? The rational, right? So there's 3 theorems going on here. The fundamental theorem of algebra says I'm looking for 3, at most, 3 different real roots. Okay. The rational roots theorem says that one of the roots could be 1. Okay. And the remainder theorem says if I plug in 1, I'll see the remainder. And it better be 0 or I'm messed up. Right? Let's do that. All right, so let's make room for this. Yeah. Let's plug in 1 right now. That's what I'm doing. So you get, plug in 1. What do you get? 2 minus 1 plus 2 minus 3. What's the remainder? 0. More importantly, is 1 a root? It is. How do I get the other 2 roots now? Now you got to divide to figure out the rest to see if that's factorable, or maybe use a quadratic formula or something. Right? If this is a third-degree equation, and I divide it by a first-degree equation, what am I going to get? Second degree. So this is at most a quadratic. Second degree, you can solve by factoring a quadratic formula. So that part's easy. Okay, so let's do that. How do you do that? Take x minus 1, since you know it goes evenly, and divide it in. All right, so you got 2x cubed minus x squared plus 2x minus 3. By the way, you got to be careful about depressed cubics. Did we talk about this? Does this ever come up before? Is this a depressed cubic? You can't divide depressed cubics. It's just too depressing. What's a depressed cubic? Do you know? Okay, we're going to say something. What? Yeah, because I need the other factor so I can factor some more. Well, if you know how to factor that, that's fine, yeah. Good luck. Factoring is dividing, by the way, so I'm factoring anyway. Is this depressed? No. What does that mean? That I have every single degree. If this is a third degree equation, isn't it? I need to have a second degree term, a first degree term, and a 0 degree term. This is technically x to the 0, isn't it? Because x to the 0 is 1. Okay. So I'm not missing any terms. What if I was missing x squared? What if the original problem didn't have this in it? It would be depressed. Now remember, that's you know this from long division. If I divide 22, dang it, regular long division. If I divide 22 into 901, I'll get an answer, right? But is that the same thing as dividing 22 into 9001? No. The placeholders matter. So you would have to have a 0x squared here, or your division algorithm would fail. The long division algorithm that we know doesn't work unless you have every single term, right? All right, now we're okay here, though, because we had the, what was it, -1 there? Yeah, so I'll just put that back there. Okay, so divide. X into 2x cubed goes 2x squared, because 2x squared times x is 2x cubed. Again, you're not dividing correctly if these don't match. 2x squared times -1, negative 2x squared. And then we are dividing, and then you add the opposite, right? Subtract is add the opposite, and what do you get? Combine like terms, what do you get? You get 0 in the first column. In the second column, you get x squared. Okay. Now, x into x squared goes x, because x times x is x squared, and x times negative x, x times -1 is negative. What did we do? No, before that. Bring down the next term. Okay. So add the opposite, and you get this. So combine, and you get 3x. Okay. Then bring down -3. Then you divide. X into 3x goes 3, because 3 times x is 3x, and 3 times -1 is -3. Then you're going to add the opposite, and guess what you get? The remainder should be 0. So that's the other factor. Yeah. Wait, one question at a time. What? I just wrote it down. Oh, the 2x squared, this guy? That was 2x squared times -1. Remember, then we added the opposite, right? Okay. Okay. Yeah, go ahead. All right, so what do we got? We've got this. We have that 2x cubed minus x squared plus 2x minus 3 equals 0. It's factorable this way. X minus 1 times the quotient that we just got. Isn't it? Yep. Been there, done that. Where were you? Yeah, well, one thing at a time. All right, now what? Now, can you factor that? You can set this factor equal to 0 and get x equals, but we knew that. That's where we started. You can set this equal to 0 and factor, maybe. Can you factor this? Is this tricky? Try. What multiplies to 6 and adds to 1? Two nice easy integers in your head? No. Not multiplying to positive 6 and positive 1. If it was negative 6, maybe. Nope. Yeah. Huh? Okay. Yeah, you got to do quadratic formula. Go ahead. Yes. Effective yield? You got to read the book. Yeah, that was in the homework. All right, so x minus 1 equals 0, or 2x squared plus x plus 3 equals 0 means that x equals 1, or x equals, now what's the quadratic formula? Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, and you get -2 plus or minus, well, that's 4 minus what? 4 minus 24. Wait, this is wrong. B squared is 1. Sorry, I copied the 2. Whoa, I squared the 2. Yeah, that's a 1 squared, right? Okay. So 1 minus what? 4AC. No, it's not a B. It's the B that I messed up. Negative B. Yes. What am I getting? Where am I looking at? I'm looking at the wrong B. Yeah. Okay. So negative B plus or minus square root of B squared minus 4 times A times C all over 2A. That's it, right? Okay. So what's 1 minus 24 is? To negative 23. So rad negative 23 all over 2. And what happens when you square root a negative? You get imaginary, so it's negative 2 plus or minus rad 23I all over 2, which is complex. Yeah. What? The denominator is 2, isn't it? Over 2 times, no. Oh, I'm reading the wrong numbers. Sorry, hang on. This is over 2 times 2, right? There you go, right? Okay. Homework? Really? Now? Oh, all right, come here. The pretest is complete? Yeah. Yeah. All right, any last second homework checks back here? Over there. All right, YouTube. Have a nice day. No, I got to